Um, Alright, so what do we have here? So this is LeetCode 74th question. Ignore this. While I was doing arrays, so I attempted this question, but this is not the right approach to do this question, because obviously question asks for something else. We'll be doing binary search over this. So yeah, I had to reattempt this because now I know what binary search is. So that's why. So the question says you are given an m cross n integer matrix. So rows and columns are not equal. Uh, with the following properties, the true properties, each row is sorted in non-decreasing order, and just a second, it's recording, right? Yep. Hello. Yep. So each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. Alright, so sorted 2D matrix. So binary search, of course, log m cross n, topics, yep, binary search, matrix, and array. Alright, so given an target integer, so given an integer target, return true if target is in the matrix, or return false otherwise. You must write a solution in O log m cross n time complexity. Alright, so I did complete my binary search in 2D array topic a few minutes ago, so I feel like this looks like exactly the same thing, but let's see how we do it on the code. So in order to get what we want, what we need is that we need to perform binary search. That's very obvious. So let's like first of all write, like assume like we have to perform binary search in like whatever, like let's assume the first row itself. So let's first of all make a function out of it that's gonna just perform binary search. So when we do that, so wait, they want it in boolean, so we'll have boolean, private boolean binary search. So what this binary search will do is that it will first of all take the matrix. Alright, so int the thing is I won't be taking like the double like 2D array right here, because we will be performing binary search only on the row that is singular, so like the singular array. So yeah, so int let's call it matrix only for now. Int matrix. Then we will be needing the row, so the row, so int row, we will be needing a column start, like the bounds for it. So we will be needing the upper bound and the lower bound. So column start and column end can be that. So int column start, and then we can have int column end, right? And of course we need the target element as well, so int target. Alright, so when we have a binary search function right here, so what we need to do is that now we need to obviously iterate, like have a while loop that goes between the column start and column end, I would say, because we have a singular row. So while column start is less than equal to column end, what we can do is we can have int mid that can be column start plus column end minus column start divided by 2. So that will be the column middle, and then we can have if condition, like if matrix no, what can be the if condition? Like we assume there is one row. So assuming that there is one row, we have a column start, we have a column end, we have a row. So in that matrix, so all right, so in that it's recording. Yep. Hello. Yep. So in that matrix, if row and mid are equal to target, all right, then return true. Yep. If that's equal to target, then just return true. If matrix is like row mid, that's target, return true, because they want the answer in boolean true value. So yeah, and if this is not the case, then if matrix row and mid greater than target, what we can do is we can have if that's greater than target, we need to tone down a little bit. That means bring end closer towards the middle. So our C end can be, that's the right logic, right? Like if row middle is like matrix, the element is greater than the target, so basically it lies, the element is lying on the right hand side. All right, so the target has to be lying on the left hand side because it's less, it's a certain it's right. C end becomes mid minus 1. Yep. Else C start becomes mid plus 1, right? If it doesn't work out, what we can do is we can return false. If you can't find the element, return false. All right, so now we have the binary search, like when we get one row, so what to do with that particular row. So we will be performing this binary search over it. But what if to get that one row, we need something, we need to search. All right, so what we need to do right now is let's break it down. We had this matrix. What we did was that we wrote the function that will be performing binary search, and now this function, when performs binary search, it will be performing that on a singular row. What we need is to have that singular row basically. So whatever the matrix will be, n cross m cross n, whatever it is, so what we need is that we need to have that row singled out. All right, we just need that row singled out, so we need to search for that row. So we can just create another function that performs that for us. So basically in that function we will be like searching, like to get the rows out of the given matrix, like on the row that we need to perform. So for example, we create another function, private int search. So this will be like an integer only. Reason being, they need the answer in boolean, so final answer will be given by this. So they need to find the element and then return the value. So here also we need to work with rows. There is no need for like boolean and everything. So the private in search, so in like when we have to search, so where do we have to search? We need to search what constraints do we need. Not constraints, not the right word, but what do we need? Like where do we need to search? We need to search in the matrix. What do we need to search? We need to search the target element. So simple int. Now this is 2D matrix. So int matrix int target. All right. So yeah. So now, like for example, if here we have m cross n. So what if, like first of all let's talk about when we have a singular case, like singular case as in we have one row. So in that case we don't need to search basically. All right, we don't need to search. And if we have 0 columns, then also we don't need to search. Yep. So the thing is, like if let's get the conditions out that are like gonna cause issues for like moving down the line. So if we have alright, first of all we need to declare a few things. Yeah, we need to declare a few things. I can't be like if rows equal 1, like I need to declare what rows is. So let's do that. Int rows equals to what's that gonna be? Int rows equals to I took row right here, so let's keep it like that. Let's keep it row. Int row equals to matrix dot length. Int call equals to matrix 0 dot length. Matrix 0 dot length. Yeah, that's I guess pretty much that we need. No, but we need that we have int row, we have int column. Here in search we need int target. Alright, so if row equals 1, if there is only one row, that means there is the length is 1. We can have our binary search. Now we use that binary search, you know, the one we created, binary search. So so we'll return binary search. Now what does this binary search require? It requires a singular matrix, 1D array basically. So we have our matrix, so we will input that. What do we need else? What else we need? That's row, that is int row. So what can the row be? If the I right here took row equal 1, so like the value of row is 1, that means there is, so let's put it as 1. I think it should be 0. I think it should be 0. Alright, let's do one thing. Let's have r start start row start, that is 0. Let's declare it the right way. Int row start, and then we have int r end. Yep, that can be row minus 1. Yeah, row minus 1. That can be row minus 1, obviously. So this is the column. I don't think we need column start, because that is handled right here in binary search, so we don't need that, I guess. What we can have is a column middle. They have a column middle right here, so they don't even require that, so let's forget about that. Let's forget about that for the moment. So yeah, here instead of just getting, yeah, I mean row is the row start. Matrix row start. What else do they need? Column start. They need a column start. So column start can be from 0. Yeah, that can be from 0. I could have also declared it right here, but it's fine. I mean, I don't need that at the moment. I can just input the value and it's gonna be handled right over here. I didn't even need our start right now, so I could have just said 0, but it's fine. What's the C end? C end for this row will be column minus 1. What's the target? Target is target. We don't know the target, so target. That's the thing. And if it is column as 0, then simply return, we can return minus 1 comma minus 1. Will this have negative elements? Yep, I guess this means that it can have negative elements. Alright, let's do one thing. Let's forget everything. Let's make it boolean. Here we return this, it goes over there, so it's fine. Here we return false, it's fine. Simple. Yeah. So now that we have dealt with the case wherein our row can be 1 or a column can be 0, what do we need to do right now is now focus on the main matrix, the given matrix. Like, how do we deal with this, as in yeah how do we deal with the matrix wherein we need to ensure that we have to, like, basically we need to remove the rows that are of no use at the moment. We took the cases wherein we can have some issues, like if there was only one row, if the columns were 0 and everything. Now what we can do is, what the right approach should be is to eliminate the row that is of no use. Like, for example, here target is 3. This row is definitely of no use. Alright, this row is of definitely no use. So yeah, to search we can eliminate this row. And how do we do that? Like, in normal binary search, what do? We take, from C start, that is this 1, we go till C end, that is the 7. What if I don't go till C end? What if I go till like C end minus 1? This is this 5. So initially I eliminated this basic 7 column. The column and the row, basically the place containing 7. Not exactly eliminated the column, I was talking about this 1D array. So I basically eliminated this element 7 basically. So what I can do right here is I can have a while loop. Yeah, I can have a while loop wherein I start from row, because now we are dealing with rows. Oh, all right, so I can start from row start, and I can go till row end minus 1. Yeah, row end minus 1. So basically, uh, what it will be doing is that it will be going till this, and row end has to be row minus 1. So the row end is this, it's going till here only in that case, because it's row end minus 1 and it's not equal to, so it's not considering row, you know what I mean. So yeah, this is how the loop will be working, the while loop, because we need to eliminate the ones that are not required. So now we can have int mid. So now we will be needing the row middle. And all right, so now if we need the row middle, we also need a column middle. You know, like how do I compare then? How do I compare the elements if I don't have a row middle and a column middle? Because my binary search is handling the column and everything, but here also I need to compare because I need to find the target. So in order to find the target, what do I need? I need a column middle, because it's a 2D matrix, 2D array. That's why do I say 2D matrix? All it is a 2D matrix, but yeah. So here int c mid can be column by 2. Like, yeah, let's keep it like that. Let's see if it gives an error when I keep it call by 2. I guess it won't, because it's like constraints say it's like from 1 till like 100. So row can be equal to 1. All right, so we figured that out. We figured out the case wherein the row can be 1. So yeah, and columns can be like till 100. So I don't think so there will be an issue. 100 by 2 it's gonna handle. Let's see if it gives an error, uh, data overflow or something. What's that called? I don't know. Something like overflow when the space is not available. So int mid can be r, nope, nothing, r start plus r end minus r start by 2. All right, so int mid can be r start plus r end minus r start by 2. See, the thing is, I just got off uh, from studying the 2D matrix thing, so it's kind of fresh in my head. So it's like less thinking required for the moment, I would say. The time it starts giving an error is the time it's gonna take more and more time. Right now I have the approach, in my head fresh, what to do. Like, consider the given m cross m matrix. What to do? Simple. Follow, like, first of all, start from the basics. Have a binary search in your head. What the binary search will be doing will be searching for like the element. All right, so while it searches for the element, how will you be able to give it that one singular row? You won't, like, so you need to search for that. You need to eliminate rows. You need to search if the rows that you are considering or eliminating are gonna have your target element or not. So yeah, so int mid can be this, and then if now it starts. So now, like, if you're given mid, let me just check one thing. Here I took 1D matrix. Yep, that's the worst. That shouldn't be there. See, that's the I was that is what I was wondering, like, why am I doing that? So yeah, it's fine. One singular row doesn't mean 1D. It means like one row, 4 columns. Yeah, my bad. So 1 4 makes sense. All right, so int matrix. int matrix, if matrix. So now we need to check, like, if now we need that if r mid and c mid, let me just have the c mid right here, int mid is like that. All right, let's name it r mid. Yeah, if r mid and c mid are equal target, then you can just simply return what can we return? If that's equal to target, then just return true. No need to go and binary search for this. But if it is not, what if it's not? If matrix if matrix r mid and c mid are greater than target, what can be done? We don't need to find out the element in this case. We need to eliminate the rows. So if like for example, like here target is 3, so if like that, if the target, what if the target was all right, so if it's like if the like if 30, if it's like 0 1 and 0 1, like 0 1 2, all right, so second row first column, yeah, second row first column, yeah, if it starts from 0, second row 0 1 2, second row 0 0 1, first column, second row first column is 30. If 30 is greater than the target, what we can do, we can move up. All right, we can move up. Here there is no need to find out in this case to perform a binary search or something. We have binary search over right here, but we need to eliminate the rows that are definitely not needed. So what we can do is we can have we are going from row end minus, if we mid minus, if it's mid minus 1, so row mid will be this, column mid will be this. I don't want the r mid because I'm eliminating the rows. I don't want that to be r mid minus 1 because then it's like, what if it was 11? What if it was 11? What if the target was 11? I don't want to lose this, so I'll consider this. So r end can be r mid. Yeah, r end can be r mid if matrix r mid and c mid is like greater than target. Yeah, r end will be shifted above because target lies above. And if our mate, let me see if it's recording. Hello, yep, it is. And if the matrix r mid is c mid, if matrix r mid and c mid are less, why am I writing that? I could have just said else r start equals to r mid. Simple. Yep. So now what does this tell? Yeah, what does this tell us? All right, what was the need of a while loop? the need of this while loop was simply just to like eliminate the rows that we don't need. That's what we did. Alright, that's what we did right here. Now we don't need this while loop anymore after the rows have been eliminated. So we'll come out of it. Now consider this case. Alright, consider this case. In this case, it's recording, right? Yeah. In this case, it's uh like suppose following this while loop, this matrix in this matrix the last row was eliminated. Alright, the last row was eliminated, and our Rn becomes the row that starts with 10. Alright, so now we have two rows. Fair. Now we have two rows, and what we need to do is that we need to search. We need to search that out of these two rows remaining with us, out of these two rows that are remaining with us, where what are the what all are the possibilities where we can find the target element. Like what do we have, like that we know we have r start. So like suppose we have r start, we have r end, we have column mid, we have r mid. So we can, you know, like go around the middles. That's what we can do, and that's what we do usually in the binary search. We can go around middles. We can, you know, like be like r plus c minus, like c mid minus r start something. So it's like what the cases that we can have are like, suppose we have a c mid. All right, we have a c mid, because out of two we can't be like dealing with r mid. That makes no sense. R mid was used to eliminate, to get the needed ones. Now we have c mid, so we'll go left and right of c mid, and using that r start we can go up and down. All right, so left and right and up and down to find out the target element in the remaining two rows that we have. Like that's one that starts with 1 and the other that starts with 10. All right, so suppose c mid is 3. Yeah, c mid is 3. What we can have is, like, we already covered the case wherein r mid and c mid give us the target element, so that will be giving us true. But if that's 5, what about 5 and 7? So r start, that is the first row, and c mid plus 1, if target element is greater is yeah, if target element is greater than r start and c mid plus 1, yeah, greater than or equal to, all right, my bad, greater than or equal to, because that's what I was wondering. Like if I'll be having like it as greater, I'll be missing out on 5. So greater than or equal to, yeah. And then the other case can be if that's less than that. So r star remains same, and c middle becomes c middle minus 1. Yeah, if less than or equal to, again less than or equal to, then r star becomes r star plus 1, because we need to now look into the other row, and then we can do the same thing. So let's write that down. If matrix r start and c mid plus 1 are greater than, are less than or equal to target, that means target is bigger than them. Yeah, less than equal to target. All right, so we can have our now binary search. Wait, let me just cross check this condition. R start, c mid plus 1 are less than target. So if it was 7 and mid was at 3, so yeah, binary search, we have our matrix we have our what else did it need? Row. Yeah, that is our start. We have our uh, C start. Do we have that over the top? Yeah. No, we don't have a C start. We don't have a C start. All right, we do have that. That is our column. Yeah, that's our column C start. So no, but wait, that will be C mid plus 1 only, na? That will be C mid plus 1 only, because see, if it's like we need to start to search, we won't be searching from the first element. That's the other case. So that is the mid minus 1. So yeah, it will be C mid only. C mid. Yeah, C mid. Start will be C mid. What the end can be, that is column minus 1, and column minus 1, and then what else do we need? Target. So that's not for us. Target, return that. All right, if now it lies on the left hand side, so if matrix uh, r start and c mid minus 1, yeah, r greater than or equal to the target, I guess that will be the right thing to say. If our c r start and c mid minus 1 are greater than or equal to target, yeah, because in this case it's because, like, what if there were more elements on the right hand side? So uh if there was two, if like there's one, what if there was 1 2 3 in the middle element? So we take c mid minus 1, and in the row 1 we take c mid minus 1 for the left hand side case, and then we say that's greater or equal to target. All right, so what can be the starting point? The starting point can be row will be row start. The ending point then will be um what's that gonna be? What's that gonna be? When we move towards the right, so we start from C mid till column minus 1. Alright, here we will be starting from C mid itself. No, but no, we will be starting from where can we start it from? Is there something we have like column start? We don't have that. Okay, we will say it's gonna start from 0. Obviously, why to think too much? Return binary search. At the moment I should, I guess, copy it because might have typing spelling error, sorry. So matrix row start, it starts from 0, it goes till C mid. Yeah, it should go till C mid. Yeah, let's we'll see. Target. Now if let's copy paste now. I won't be writing it again and again. If this is the control C, now we came down, so it's gonna be +1 and C mid what did we copy? Let's first of all keep it plus in the order. If that's the case, if that's the situation, then we can have binary search, control C. We can have binary search and we can have matrix r start plus 1, c mid column minus 1, target. If control C, r start c mid minus 1 greater than target, then we can have yeah. Yep. All right, let's verify the, you know, given conditions. All right, so uh, here if it gets equal, if it's caught, fair enough. All right, if it's like in other rows that we are considering at the moment, if r start and c, suppose this is the middle element, c mid will be this only, 0 1 2 3, this will be the mid, c mid this will be this. All right, this is a c mid. If target is greater than c mid plus 1, greater or equal to so we are considering these elements, c mid plus 1, c mid plus 1, target can be 5, so it gets on the equal to condition, it can be 7, so it's on the greater condition, fair enough. Binary search will be performing from matrix, this matrix. We will be having r start as 0, that is verified over the top. C mid will be the given, the one we will find from here. Is it considering it as equal c mid, the start point? So I guess I should put plus 1 right here, I guess, because here we have while start is equal to end, you know, so c start is equal to c end. This case has already been talked about. All right, so let's put it as plus 1. If it give error, I'll verify it, no worries. All right, till column minus 1, this is this element. Yeah, fair enough. Yeah, now this case, if r start this and c middle minus 1 is this element, yeah, is greater or equal to target, either is greater than target or it will be equal to target. I am a little confused with this case that I have written. Why? Because it's like we need to search for this area, right? C mid minus 1 has to be there. Yeah, C mid minus 1 has to be there. We need to consider this element. But now the case is that what if there were more elements? So let's assume here it was 4, here it was 3, here it was 2, here it was 1. Yeah. Now, when here it was 4, here were many elements more. So C mid minus 1. And what if the target was less than that? Alright, so my bad. The case works. The case works perfectly fine. So if it's like that, so if this is greater than target, so if target is less than, basically, if target it is less than or equal to c mid minus 1, that is this, it works. Binary search will start in this matrix, r start will be the r start. Yeah, that's the thing. We will be taking it as 0 because this is the 0th column, going till c mid, but let's do it mid minus 1. Yeah, then target element. The thing is that if I'm assuming elements right here, that can be the possibility, or that can be equal or something like r start c mid minus 1 is greater or equal to target. So yeah, it won't be going beyond 0. You know what I mean? It won't be going beyond 0 because I have set that as 0. But for this case, that like c mid plus 1, uh, when the target is greater than it, c mid plus 1, when the target is above that, like greater than that, so it's like, what if the loop doesn't perform? Like, what if target is like getting like not in it? Like, I mean, we need to, I guess this thing can give an error. Like, what if it doesn't consider the last element, or last element right here, because it's like column minus 1, this is this element, uh, column minus 1 till the point it's less than or it's equal to hmm let's keep it as and the row matrix. I guess this gives an error, like when I studied it. So yeah, while studying it, I guess, yeah, this will give an error. Let's keep it r start till column minus 1 is greater than target or equal to target. Because I feel like when we are going till 0, it's gonna stop right there. But just to consider this last condition in all the cases, I guess this needs to be done. Like, yeah, I guess. I guess that's. If I remember, yeah, we should. If I remember while I was doing this topic, yeah, we should. Let's see. We were on this case, so r start plus 1 gets over here, and c mid plus 1 gets over here, and this is 16th plus target. Here also, I think I should be like mid plus 1. Here also, I should be like mid minus 1. Wait, should be r start is 0. Why did I take c mid as the start? Why did I do that? And wait a second, why in every case column? Here it shouldn't be column minus 1, it should be c mid. Yeah, this should be 0. Yeah, c mid plus 1, c mid plus 1, c mid plus 1. Yeah, let's try. Where? Congratulations. We didn't do what's needed. Cool. So what can be the answer but return binary search or return search? Return search, because search is performing binary search. So here we can return search. How about now? Obviously, my bad. How do I initialize search if that's a boolean? How do I do that? How do I do that? Wait, how do I do that? If search is a boolean, how do I initialize that? This might be the most stupid thing I'm stuck at. I created uh, everything. All I need is to run the code, but I need to have something here. What that can be? I can't just return it. Alright, so this requires int target and everything. So why can't I just take this completely and then space right there? Because it's searching matrix, so yeah. So here. Yep, this is the function that's going to be considered boolean. This is gonna go right here. Boolean is gonna return false if it's not. It's gonna again have a return statement right here. Yeah, it needs a return error class interface enum record expected diamond 44. Wait, what? How is that giving an error? How is that giving an error? This function ends right here. Return search matrix. Am I doing something wrong? My goodness. Let's hide it. If it's gonna be wrong, I need to return something. But yeah, I need to return something. Let's not hide it. Let's return it. All right, my bad. 1, 2, 3. Cannot find the symbol search matrix. Why? What went wrong? How can you not find that? How can you not find that? Am I returning wrong? Am I doing that wrong? Am I that dumb? How to initialize a boolean? How to initialize a boolean in Java? Declare a boolean variable. String boolean is match false. Is match string boolean is match. What use boolean instead of boolean, which can be a null. Boolean is match. Find use keyword. If is match true. Alright. So what I can do is, I guess I am doing it wrong. I need to declare it outside. But how will that make sense? But it will make sense, I guess. But it won't. That's concerning. I did the code and now I'm messing up. First of all, let's try that boolean thing. Let's get it away. Boolean answer equals to search matrix comma target. Boolean answer is search. It's search. It's matrix and target. So what we can return is, the moment this is the thing left, we can return answer, and you can have this completely out of that. How about now? Oh my goodness. What do you want me to return outside the function? Why do I struggle with return statement so much? My code is done. For my part, at least. Let's remove excessive stuff to understand what the error is. Alright, I don't want to remove this. Yeah. I need to return search because search is having my binary search. So I don't have to return binary search. I need to return search because search is performing my binary search. So search is the everything. So search has to be returned. So boolean answer is going to be search. Yeah. How? Alright, let me look at the submission that I made to look at the return thing. I can't open it a new tab. This was the solution that I used. Return to return false. Return to return false. Yeah. Public boolean. I don't have to return anything out of it. I don't need to return anything in it. Yeah. So I need to return nothing out of it. Just in it. Private boolean binary search return false. What does this return? Does it? So they need a return statement right here, right? But I am performing binary search. Let's return false if it's not the case. Ooh, it works, it works, it works. Is it gonna work for everybody? Runtime error? Huh? Index out of bound? Why is the error not visible here but here? The runtime errors are visible here. Why is that happening? Cross. Control enter. Don't show the error here. Show it here. I need to edit my code as well. Thank you. In this line, yeah, let's try to remove this. Can I comment this out? Nope. It will take the whole line with it. Now, that condition was there to prevent that. That was the beauty of that condition. It was there to prevent it, but this still, like, blah. This still happened. Alright, what can be the possible solution for that? This is right. Alright, let's do one thing. Let's take it till mid. Let's see what happens. Let's see what happens. Let's see. Accept it. Yeah, error. I have to take cmid plus 1. I have to take less than. Wait. Yeah, target should be less than row star and column minus 1. That should be there. Let's dry run on this. Do I even use the dry run term correctly? 1,3. So it is, if the matrix start is c plus 1, I have equal as well. The code works for 13 test cases but not for this one. So it's like if in matrix, if in the matrix, wait, target is 0, so it's not in the matrix. So return false. Like, seriously, how is that? Wait, you come out of the while loop. When the while loop breaks, return true. My goodness, the target isn't, so it should be returning false, but due to the condition it gets stuck over right here because it won't reach there and it won't even reach here. In the binary search, I mean, yeah, here. Index out of bound exception. R start cmid plus 1. Here, you don't have that. Alright, you have that. This is one row, there are two elements. Plus 1, if the target is less than or equal to, and the matrix third should be column, like row 1 and column minus 1, the last element should be greater than or equal to target. What's the error? How is it like index out of bound? Index 1 out of bounds for length 1. Length 1. Where am I using length as 1? Row is 1, that's the thing. How does that make sense? How does that make sense? Row is 1, and here row is 1. Our start is from 0. How is that an error? Wait. Oh, my bad. This is 1 and this is another. They're not equal, they're not same, they're not together. So C mid plus 1 will, if, like, now here there are two rows. Alright, there are two rows. I consider for the row 1, here we have two rows, column 0. But here we have here it would have gone like R start, like the middle would have been easily found out. Two rows, so yeah, this one would have in the middle. So 0th one would have in the middle, and if matrix middle, R middle, C middle is like there's only one row, so 1 by 2 is 0, so this is only, that's equal to target, get the target. That's not equal to target, that's greater than target. No, that's not greater, that's greater than target. So Rn equals to R mid. So this got covered. This became end. Then we talked about, now this is the end, this is the start, and everything. We are not even considering this. Alright. So we are considering this. So R start from 0, exactly. C mid plus 1. C mid is also 0. C mid plus 1. There's no plus 1. So what to do? There's no minus 1. So what to do? That's why I have this condition that it should, like, column. So now what it is having is column by 2. Column is 1. Column is matrix for, like, matrix 0th row length. It is 1. So column minus 1. So R start this, column minus 1, this only. Yeah, 0 here, 0 will be here. This only should be greater or equal to target. Yeah, it is. It is greater or equal to target. Alright. So both conditions should be true, then only it's gonna execute. Here let's check. R start is this, C mid is this, C mid plus 1, you don't have that. Alright, should be less than target. You don't have C mid plus 1, and that should be less than target. Let's have plus 1 right here, and let's remove plus 1 from here, which I don't think should be the right thing to do, but let's see. Oh, that's gonna work. Obviously, how I should have thought. Now gonna give error for the next. It shouldn't give error for the next, because we are not considering 3 in this case. False. Expected true. Now the case is the case is 1. Now the case is 1. Alright, so why is it giving false? How I get it. You couldn't find answer in the two conditions, so you return false. But you should have. Now it's, I guess it's gonna mess up the code. Yeah, it will obviously, because yeah. No, wait, what? Output is all right. So another thing is, it's, I guess the code works fine till now. I guess it's in true or false. Uh, Let me just review this true and false thing. It's gonna start from the start. Here it's nothing to be worried about, true and false, because here I'm not returning anything. See, if the boolean doesn't work, if it works, return true. If the binary search doesn't work, you have to return false. All right. If you find this, you return true. You have to return false if the columns are 0. All right. And if this if condition works, if this, if not this, then this, if not this, then this, if not this, then this. I don't know what is the need of this. Like, if I remove this, they show error, but technically, yeah, it's like, bro. They want me to return something. They want me to do that. If this while loop doesn't work, what if I return false? What if? Error, because now the condition below return won't be considered. Can't do that. Always hated the return statements, could never figure out where, but let's try, because I guess this is a time to figure them out. Let's try to return this. It's gonna be false only, it's gonna be false. If nothing is working, you have. Alright, what am I returning false to, by the way? What am I returning false to? I'm returning false to after this if condition. I guess now it's talking about the if conditions, because after this if condition, if it's gonna come false, what will it be if I say it's gonna be true? What's gonna be the issue? The code here won't work. Why it won't work? Because 1 3 and everything. Here the target element is 13. So yeah, if I can't find in any case, the target element is 13. Alright, it's 13. So can I have an else condition? Else return false. Still wants me to return something. Yeah, it will. All I can do is return false initially, Target is 1, target found is getting false. Why after target found is getting false? If target is found, how can it get false? Because target is gonna lie in this here region only, so it has nothing to do with this false. Alright. You will be finding the target right here by the binary search, because target was found. Target was found. How are you getting false? Means target not found. That's the issue, I guess. Target not found is the issue, I guess. What if? I shouldn't. Um, I guess you should be able to find that out. What if it returns true? It shouldn't. It shouldn't. What? Yeah, because it's like binary search has to break to return true. It makes no sense. Yeah, exactly. It has to. Yeah, yeah, exactly. It can't be right. Wait, target is 0. You don't have it. Anyways, the logic is logic. It has to return false. If the binary search break, it will return false because the element is then not found. Right. So code is having no issues, I guess. All right. I don't have to waste more time because it's not gonna be the way I want it to be. So let's. So if the while loop breaks, I mean, what happens after the while loop? All right. So after we have found out the while loop stops right here, we come right here, we talk about all this. Uh, um, Control C. Where is the error? Primarily in the search method below detailed down, missing return statements. What should I return? Inside the search method, you are calling binary search multiple times but not returning its results in certain places. I am calling binary search, that's very true. Yeah, I called it right here. Ah, my bad. Return binary search. Return binary search. Return. I have to return it. Return. Get away. Of no use. Please work. Please work. What? Missing return statement? I returned binary search. I returned it. What do you need else? What else do you need? Return false? Is that what you need? Acha, that's fine. Let's try. Output comes false. Expected should be true. Why is it coming false? Alright, let me just deal with these conditions. But I did deal with them. What if I do it back at, like it was? Mid plus one. What if I do it that way? Code's gonna work, I guess. This is gonna show error. Yeah. Index out of bound. I get that. Yeah. See mid plus one. You don't have mid plus one space. It's fine. It's completely fine. Is it recording? See, it's like 1 hour 19 minutes. It shouldn't have been that long. The code was done way before, but it's fine. When if errors are present, the code isn't complete, I would say. Control A, Control C. I need to now. Alright, it's visible back again. Yeah, I need to do my research right here. If logical condition overlap, R start. Where is it happening? R start. I'm dumb. I'm so dumb. No, but I changed that. R start C mid plus one target. Yeah. Plus one C mid plus one. The condition do not clearly handle all possible cases that might conflict either. Incorrect index usage. Why? Alright, fair enough, fair enough. Incorrect handling of a single row or column. Handle the edge cases. What do you have for me? What do you have for me as the improved code? Matrix row mid target. Yeah, that's what I did. That's what I did. Binary search. Alright, let's forget that. I didn't false. It's fine. That's nice. If matrix at length, this is this. If row is equal to 0, if column equals to 0. So you want me to make the row equal to 0, column equal to 0. Return false, return false. If row equal to 0, then how will columns exist? No, but alright. Yeah, so column equal to 0 I guess handles it for empty matrix, right? I don't need to add this as well. They both like coexist. While R start less than R, yeah, fair. Equal target, yeah, true. Yep. Mid, fair enough. Here's the same thing. Yep. Check 4 quadrants. That's what I did. R start. What? I mean, okay. R start. Row start. Yeah, if it's this case, C mid. See, I like, okay, but I had that changed, but yeah. C mid. C mid. 0, C mid minus 1, 0, C mid column minus 1, true. Row start plus 1, row start plus 1. C mid. C mid minus 1. When you have row start plus 1, you have it starting from 0 till C mid minus 1, starting from 0 till C mid minus 1. Okay. And no, C mid. R start plus 1, C mid column minus 1. R start plus 1, C mid. Column minus 1, C mid column minus 1. You saying that's gonna work? You saying that's gonna work? I guess pretty much I had that same exact code as well. I remember. Still giving me an error. Why? Dog, why? This line is giving me error now. I guess probably I should just like remove this. Like, still gonna give me an error. C mid -1. I mean, alright. Oh my goodness. Wow. Nice. What? How are you getting an error? See, it's like starting and ending at this place. Missing a line in the second R plus C mid is greater than target. It is less than target. Let's come right here. How can I be so dumb? I mean, this. What? Less than equal to. Alright, too much code written, I guess. I am missing out on the silliest things. You don't have this as like your middle is gonna be this. Alright. 0, 1, 2, 3. This is gonna be the middle. The middle is target. Like target is less than. Alright, this is the case you're considering. Target is less than all this. So yeah, binary search will be starting from r start plus 1, like, you know, if this thing and this thing, like from here. All right. You lie in the r plus 1 thing. So it will start from r plus. All right. So you will be considered C mid. This is the C mid that you have for yourself till column -1. It's gonna go till column -1. It's right here, but wait. R star plus 1 is gonna give this thing C mid. So see, what's C mid is like this thing, and the target is less than that, right? Target is less than that or equal to, so it's less than that. It's greater than it. So it should start from R plus 1. That's true. Second row. C mid should be the starting point. No, the conditions have switched. That is my mistake. If the target is greater or equal, and here less than equal. Yeah. Finally, I would say I had the logic with me. I did write the code right, but I did write the code wrong because stupid syntax errors, forgetting the return statements. I don't know how do I do that, messing up with the signs. I did learn that you need to keep C mid as it is. No need to +1 -1 that, because obviously that's gonna create an error. So that's the thing. Yeah. So I hope I don't need this the next time. I am trying to not use it at all. So yeah. Thank you.